Welcome back, everyone. In the last part, we explored how constructors initialize objects and how important they are for creating consistent, reliable programs. Now we're moving deeper into the world of constructor types, overloading constructors and methods, default values, and a fantastic C# feature called object initializers. Every concept here is designed to make your code cleaner, more flexible, and more powerful. Let's get started. Understanding different types of constructors is vital for real-world programming. In C#, there are four main types. Default constructor initializes fields with default values. Parameterized constructor allows flexible initialization with specific values. Copy constructor creates a new object by copying another object's values. Static constructor initializes static fields for the whole class, not individual objects. Each constructor type supports the concept of controlled object initialization, ensuring consistency and reliability across your application. Here's an example combining different constructors. The default constructor initializes a basic employee with unknown values. The parameterized constructor creates a specific employee with a given name and ID. This teaches us the principle of flexibility. Instead of having one rigid way to create objects, we provide options for how objects are born. Constructor overloading means creating multiple constructors with different signatures. C# automatically picks the correct constructor based on the number and types of arguments you pass. No arguments, default constructor, one argument, one parameter constructor, two arguments, two parameter constructor. This illustrates the key programming principle of polymorphism. The same function name behaves differently depending on the inputs. Every value type in C# has a default value. Here's a few examples. Int default value, 0 bool, default value, false char default value, null character. Understanding default values is crucial because whenever you create an object without explicitly setting fields, C# assigns default values behind the scenes. It guarantees that your variables always have some initial state, no random garbage memory like in C or C++. You can define constructors that take parameters to initialize fields directly. Constructors with parameters allow you to customize object creation, making sure objects start with meaningful data rather than default or meaningless values. This is part of writing reliable and meaningful code right from object instantiation. Here's a simple employee class with a parameterless constructor. This ensures that every new employee gets a default pay rate if none is provided. It highlights a critical principle. Don't leave your objects in an undefined or invalid state. Now we define a parameterized constructor. This constructor allows flexibility, setting a different pay rate for different employees. It teaches the principle of object specialization. Objects can be customized at creation to reflect their unique real-world counterparts. In this example, the employee class has multiple overloaded constructors. Default constructor, constructor with just name, constructor with name and pay rate. Constructor overloading allows code reuse and flexibility, letting you create objects in the way that best fits each situation. Just like constructors, methods can also be overloaded. Same method name, different parameters, number, type, or order. This demonstrates the concept of polymorphism again. Different behaviors with the same name depending on how you call it. Overloading is an essential way to simplify code while keeping it powerful and adaptable. Important rule: overloaded methods are distinguished by their parameter list, not by their return type. If two methods have the same name and parameter signature but different return types, C# gives a compiler error. This reinforces the idea that method signatures must be clear and unambiguous to the compiler and to humans reading the code. Just like methods, constructors can also be overloaded. You can write multiple constructors with different parameters. But important rule: only one parameterless constructor allowed, whether default or custom. This supports code flexibility while preventing ambiguity during object creation. Here's an employee class with overloaded constructors. Default constructor, constructor with ID only. Each constructor gives you different levels of control at object creation. Again, the focus is on flexibility, clarity, and correctness from the moment objects are instantiated. And here's even more overloading. Constructor with ID and salary. Constructor with a character code. Notice, overloading allows different types of arguments, string, double, char, enabling objects to be initialized from different sources of information. This program demonstrates multiple constructor calls. It shows how constructor overloading lets the same class create different kinds of employees based on how much information you have at creation time. Object creation becomes much more expressive and natural. Constructor initializers in C# allow one constructor to call another. This avoids repeating code and ensures centralized initialization logic. It's an example of the programming principle don't repeat yourself, dry. Write logic once and reuse it everywhere needed. In this class, all simpler constructors redirect to a main constructor with two parameters. Constructor initializers streamline your code, reduce bugs, and make maintenance easier. Now let's talk about read-only fields. Read-only fields can only be assigned during declaration or inside a constructor. Once assigned, they cannot be changed later during runtime. It supports the principle of immutability, making sure some aspects of your objects never change after they're initialized. Here's what happens if you try to modify a read-only field after construction. MyAssistant.idNumber equal 3456 will give error, the compiler protects you. Read-only fields are important for building safe, predictable, and tamper-proof classes. Here's the deeper structure of read-only in a class. The idNumber field is marked read-only. It can only be set inside the constructor. This guarantees that once an employee is created, its ID number can never be changed later. Perfect for critical identifiers. Object initializers let you set property values right at object creation. This saves you from writing tons of constructors and gives you fast, clean initialization code. This demo shows how an object initializer sets properties instantly during creation. idNumber is set using the initializer. Salary is set inside the constructor. Object initializers combine the power of default constructors and flexible property setting. Here the program shows that an employee is created, initialized, and ready to use in just 2 simple lines. Clean, fast, and elegant coding. You can even initialize multiple properties at once. Object initializers eliminate clutter and make object creation more readable and less error-prone. The box class shows how default constructors and properties work together. If no values are provided, the box is initialized to height, width, and depth all set to 1. Again, we see the principle. Always give objects a meaningful, safe default state. Finally, this demo shows different boxes initialized differently. Box 1 has a height only. Box 2 has a width only. Box 3 has a depth only. This showcases the flexibility and simplicity that object initializers bring to modern C# programming. In the next part, we'll move even deeper into object-oriented programming by exploring advanced class behaviors, relationships between classes, and the power of inheritance. Until then, keep practicing, keep experimenting, and keep thinking like an engineer, always designing for clarity, safety, and growth. See you in the next session.